Hello students, welcome to the lecture on storage types and control statements. And after the lecture we will be able to learn the following objectives. Understand the storage types. Explain the automatic and external variables. Describe the control statements. Define the while and do-while loop. Explain continue and break statements. Let's start with a brief introduction of storage types and control statements. A scope in any programming is a region of the program where a defined variable can have its existence, and beyond that variable cannot be accessed. C programming language is popular for its capability of decision-making. The storage class determines the part of memory where storage is allocated for an object, and how long the storage allocation continues to exist. Statements fall into three general types. Assignment, where values, usually the results of calculations, are stored in variables. Input-output data is read in or printed out. Control, the program makes a decision about what to do next. Let's discuss the storage types. Storage class specifiers in C language tells the compiler where to store a variable, how to store the variable, what is the initial value of the variable, and lifetime of the variable. The syntax is as shown. There are three places where variables can be declared in C programming language. Inside a function or a block, which is called local variables. Outside of all functions, which is called global variables. In the definition of function parameters, which is called formal parameters. The lifetime of a variable or object is the time period in which the variable object has valid memory. Lifetime is also called allocation method or storage duration. A storage class defines the scope, visibility, and lifetime of variables and/or functions within a C program. These specifiers precede the type that they modify. There are some storage classes which can be used in a C program. Auto storage class, static storage class, extern storage class. The auto storage class. The auto storage class is the default storage class for all local variables. Integer mount, auto integer month, auto can only be used within functions, that is, local variables. The static storage class. The static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program, instead of creating and destroying it each time it comes into and goes out of scope. The extern storage class. The extern storage class is used to give a reference of a global variable that is visible to all the program files. When one uses extern, the variable cannot be initialized, as all it does is point the variable name at a storage location that has been defined. Let's now talk about automatic and external variable. Automatic variable. Automatic variables are allocated space in the variable on the stack. To declare a variable, automatic storage class auto is specified. Auto int n, when one declares a variable, if the omitted variable storage class is automatic. Auto int a, when one declares an automatic variable initialization to be made implicit initial value is undefined. The scope of an automatic variable is only for the block, or any block within the block, in which it appears. All variables declared within a function are auto by default. A variable can be defined as automatic by placing the keyword auto at the beginning of the variable declaration. External variable. All variables one has seen so far have had limited scope and limited lifetimes. However, in some applications it may be useful to have data which is accessible from within any block, and/or which remains in existence for the entire execution of the program. Such variables are called global variables, and the C language provides storage classes, which can meet these requirements, namely the external and static classes. Register variable. Register variables are a special case of automatic variables. Automatic variables are allocated storage in the memory of the computer. However, for most computers, accessing data in memory is considerably slower than processing in the CPU. These computers often have small amounts of storage within the CPU itself, where data can be stored and accessed quickly. These storage cells are called registers. Register variables behave in every other way, just like automatic variables. They are allocated storage upon entry to a block, and the storage is freed when the block is exited. The scope of register variables is local to the block in which they are declared. Rules for initializations for register variables are the same as for automatic variables. Static variable. As one has seen, external variables have global scope across the entire program and a lifetime over the entire program run. The storage class static similarly provides a lifetime over the entire program. However, it provides a way to limit the scope of such variables, and static storage class is declared with the keyword static as the class specifier when the variable is defined. These variables are automatically initialized to 0 upon memory allocation, just as external variables are. Static storage class can be specified for automatic as well as external variables. Static automatic variables continue to exist even after the block in which they are defined terminates. Thus, the value of a static variable in a function is retained between repeated function calls to the same function. The scope of static automatic variables is identical to that of automatic variables. Example, it is local to the block in which it is defined. However, the storage allocated becomes permanent for the duration of the program.
What is a variable and how we can declare a variable in C, how we can assign the value to that variable, and how we can retrieve the values from that variable. So let's get started. All of you know that a variable is a name given to a memory location. So in C, if you want to use a variable, you have to declare it. So first we're gonna see how we can declare a variable. So first you have to write the type of data you want to store in that variable. If you want to store an integer data in that variable, then you have to write int. Or if you are storing a floating point number, then you have to write float. And if you are writing a character data or a character, then you have to write char. So that is called the data type. So it just indicates what type of data will be stored in that variable. So here, okay, first let me show you the syntax. First it's going to be data type, then the name of the variable, then a semicolon. That's it. This is how you can declare a variable. So first here, for the demonstration purpose, we're gonna create 3 variables. So first I want to store my age. So my age is a whole number, and it's an integer value. That's why I'm gonna write int. That's because I'm storing integer data in that variable. Then the variable name, so I'm gonna call it age. If you want to give it any other name, you can do that, no problem. So then I want to store my weight. So my weight is 50.5, so it's a floating point data. That's why I'm gonna write float, then weight. So the next one is I want to store my sex. That's why I'm gonna write char, and the name of the variable is sex. That's it. Now we have 3 variables, or we have defined 3 variables here. So now what we want to do is we want to assign some value to these variables. So to assign the value to a variable, we're going to use the assignment operator. So first you have to write the variable name. So here first we want to assign the value to this variable age. So that's why I'm going to write age, then the assignment operator, then the value you want to store in that variable. So I want to store my age, that is 23. That's it. A semicolon. So next we want to store my weight. It's going to be weight, then assignment operator, then 50.5. So next I want to store my sex. It's going to be SCX equal to, in single quotes we have to write M. That's because a character constant is written in single quotes. So this is it. So we have declared our variables, and we have assigned the values to these variables. So the last thing we want to do in this tutorial is we just want to print out the values stored in these variables. So that's why we're going to use the printf statement, and in printf statement we're going to use the format specifier which specifies the type of data is referenced. So first we want to print the data or value stored in this age variable. So that's why this age is of type integer. We have to write the format specifier as %d, then leave a space, and then we want to print the data which is stored in this variable weight, and this weight variable is of type float. That's why we have to write the format specifier %f. Then I'm gonna leave a space. Then we want to print the data stored in this variable sex, and this variable sex is of type character. That's why we need to specify format specifier as %c. So then we need to refer the variables corresponding to these format specifiers. So first we refer our age variable, then the weight, then the sex. So this is it. I'm gonna save it, compile it, and run it. So as you can see here, it just printed 23, that's my age, then 50.5000, that's my weight, and m, that's my sex.
We shall discuss about control statements. Control statements enable us to specify the flow of program control. Example, the order in which the instructions in a program must be executed. They make it possible to make decisions, to perform tasks repeatedly, or to jump from one section of code to another. There are 4 types of control statements in C: decision-making statements, selection statements, iteration statements, jump statements. Now let's talk about while and do-while loop. The while loop repeats a statement until the test at the top proves false. Syntax is shown here. A while loop statement in C programming language repeatedly executes a target statement as long as given condition is true. Do-while loop. Unlike for and while loops, which test the loop condition at the top of the loop, the do-while loop in C programming language checks its condition at the bottom of the loop. Syntax is as shown here. A do-while loop is similar to a while loop, except that a do-while loop is guaranteed to execute at least one time. For statements. The for loop works well where the number of iterations of the loop is known before the loop is entered. The head of the loop consists of 3 parts separated by semicolons. The first is run before the loop is entered. This is usually the initialization of the loop variable. The second is a test. The loop is excited when this returns false. The third is a statement to be run every time the loop body is completed. This is usually an increment of the loop counter. The for loop is extremely flexible and allows many types of program behavior to be specified simply and quickly. Nested loops. In many cases, one may use loop statement inside another looping statement. This type of looping is called nested loop. In nested loop, the inner loop is executed first and then outer. The nested loop must be used to input or output multidimensional array elements.
Now, what is nested if-else? It's basically an if-else within the body of another if statement or the body of an else statement, right? So what I mean is that it is fine if we write an entire if-else construct within either the body of an if statement or the body of an else statement. And I'll just demonstrate the thing to you guys through a program. And as you can see, for this tutorial, I've created a file and I've named it. It's called nested_if_else.c. On line 1, I have a comment and I have the header file and the main function in there too. So we can type in the code, and the program is going to be really simple. What I'm going to do is I'll declare a variable. I'll ask the user to enter either 1 or 2 as input, and then I'll store the input in the variable, and then I'm going to use if to check whether the input entered is 1 or 2 or if it's something else. Right, but I'm not going to just use if, I'm going to use nested if else, and that's how we're going to see what nested if else is. So let's just get started. I'll declare the variable first. I'll call it a, and I declare it by typing in int space a, and on the next line I'll use printf to display a message to the user on screen instructing him about what he's supposed to do. So enter 1 or 2. That's the input we expect, and then I'll use scanf with the %d format specifier here because our variable is of the integer type, and I provide scanf the address by using the address of operator there, the name of the variable, and now I'm going to use if to check whether the value that's provided to us is 1 or not. And the way I do that is by having the test condition A equal to 1. That is, we'll have to use the equal to symbol twice here because we're going to perform an equality check whether A is 1 or not. And within the curly braces, I'll use printf to display the message you entered 1. Right? And this printf statement would get executed only if the input that's provided is 1. Now, what if the input is not 1? Well, for all those cases, we'll have to have an else block, and within the else block, we are going to check whether the input provided is 2 or something else. And we're going to use an entirely new if-else statement to do that. Right? So within this else block, we're going to have another if statement, and the test condition for this if statement is going to be A equal to 2. That is, we're going to check whether the value that's stored in A is 2 or not. And if it is, then within the curly braces for if, we're going to have a printf statement that's going to display the message you entered 2. Right? Pretty simple that is. And if the input provided is not 2, then we're going to have an else statement that's going to correspond to the second if statement, and it's going to cover all other cases. So within the curly braces for this else, I'm going to have a printf statement. What am I doing? And within double quotes, I'm going to display the message, what's wrong with you? Right? Put a semicolon to terminate this statement. I'll save the file and click on build and run. Let's see the output first, and then I'm going to talk you guys through the program one more time. So in the output window, I see the message enter 1 or 2, and if I type in 1 and press the enter key, I see the message you entered 1 on screen. And let me run the program again. This time I provide 2 as the input. I press the enter key and I see the message you entered 2. And if I provide something else as the input, like 15, and press the enter key, I see the message what's wrong with you. So all the cases here have been covered.
If-else statements. This is used to decide whether to do something at a special point or to decide between two courses of action. Switch statements. This is another form of the multi-way decision. It is well structured but can only be used in certain cases where only one variable is tested. All branches must depend on the value of that variable. The variable must be an integral type. Each possible value of the variable can control a single branch. A final catch-all default branch may optionally be used to trap all unspecified cases. Now we shall understand the break and continue statements. Break statements. It is used to exit from a loop or a switch, control passing to the first statement beyond the loop or a switch. Syntax is as shown here. With loops, break can be used to force an early exit from the loop, or to implement a loop with a test to exit in the middle of the loop body. A break within a loop should always be protected within an if statement, which provides the test to control the exit condition. Continue statements. The continue statement in C programming language works somewhat like the break statement. Instead of forcing termination, however, continue forces the next iteration of the loop to take place, skipping any code in between. For the for loop, continue statement causes the conditional test and increment portions of the loop to execute. For the while and do, while loops, continue statement causes the program control passes through the conditional tests. Go-to statements. The go-to statement has a well-deserved reputation for being able to produce unreadable spaghetti code. It is almost never necessary to use one, and they should be avoided in general. However, on rare occasions, they are convenient and safe. A go-to statement provides the ability to jump to a named label anywhere within the same function. Comma operators. A comma expression contains two operands of any type separated by a comma and has left to right associativity. The left operand is fully evaluated, possibly producing side effects, and its value, if there is one, is discarded. The right operand is then evaluated. The type and value of the result of a comma expression are those of its right operand, after the usual unarray conversions. The result of a comma expression is not a value. The primary use of the comma operator is to produce side effects in the situations. Calling a function, entering or repeating an iteration loop, testing a condition. Other situations where a side effect is required, but the result of the expression is not immediately needed. Now in the end, let us summarize what we have learned in this lecture. Control statements are elements in source code that control the flow of program execution. There are blocks using AND, loops using for, while and do while, and decision making using if and switch. Storage class specifiers in C language tells the compiler where to store a variable, how to store the variable, and what is the initial value of the variable and lifetime of the variable. The static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program, instead of creating and destroying it each time it comes into and goes out of scope. Automatic variables are allocated space in the variable on the stack. To declare a variable automatic storage class, auto is specified. In many cases, one may use loop statement inside another looping statement. This type of looping is called nested loop. In nested loop, the inner loop is executed first and then outer.